Hello everyone. Welcome to part 2 of the polymer resin manufacturing example. In this video, I will demonstrate how to separate equipment into different suites, track production activities, and update the schedule to resolve conflicts. Picking up where we left off in part 1 of this video series, let's take another look at the resin production process. This time, some of the equipment is allocated to Suite 1 and some is allocated to Suite 2, as shown here. This is a useful case for understanding how to use SchedulePro to model equipment trains, sometimes referred to as production lines. Note that for the sake of simplicity, this example does not include equipment changeover matrices. As with the earlier examples, in this example, the raw materials are fed by a single transfer line, RMTL, into one of the 4 reactors, and only one reactor can be charged at a time. However, unlike the earlier example files, the reactors, wash vessels, and centrifuges are split into 2 production suites. Suite 1 includes 2 reactors, 3 wash vessels, and 1 centrifuge. Suite 2 also includes 2 reactors, 3 wash vessels, and 1 centrifuge. A batch that is started in a certain suite must remain in that suite until it goes through centrifugation. The centrifuged solids, coming out of CF1 and CF2, are then stored in mobile totes. Within the equipment database, these totes are specified as multitasking units which can perform unlimited parallel activities. This specification was made on the Properties tab of the ST equipment item in the resin plant facilities equipment list. The specification of unlimited parallel activities is equivalent to having an unlimited number of totes. This ensures they will not become a scheduling bottleneck. The 2 dryers, DR1 and DR2, are in another part of the building, and they are not linked to the production suites. Therefore, any batch can go to either dryer. Furthermore, just like in the previous examples, all reactors are the same size, all wash vessels are the same size, and both centrifuges are the same size. As a result, any polymer resin recipe can be run in either suite, and campaigns of the different recipes will need to share equipment. In other words, there isn't a dedicated equipment train associated with each specific recipe. Note that although this particular example assumes all vessels of a given type have the same capacity, this is not a required assumption in SchedulePro. SchedulePro allows you to specify different capacities for different vessels. In addition, SchedulePro can check to see if a given vessel's capacity is sufficient to meet the capacity requirements of a given procedure. If the vessel's capacity is inadequate, SchedulePro will not use that vessel for that particular procedure. In order to use suites, the following suite definition and characteristics should be kept in mind. First, suites contain sets of equipment that may be used together within a recipe section. If a recipe section is set to run in a suite, all unit procedures in that section will be assigned to equipment from the same suite. Equipment may belong to only one suite. Equipment that does not belong to any suite may only be assigned to procedures in sections that do not require a suite. Suites may also be connected to one another. If 2 sections are set to run in suites, and the 2 sections are also set to require compatible suites, the unit procedures will be assigned to equipment from compatible suites. If no appropriate set of equipment can be found, then a feasible schedule cannot be produced. To add suites to a project file, first select the relevant facility within the Facilities pane. Then click the Edit Facility Suites button. This will bring up the Suites dialog. Here you can add or delete suites. You can also edit suites in order to assign equipment to specific suites and specify connections or compatibility between suites. In this example, the suites are named L1 and L2. As shown on the diagram a few minutes ago, each suite contains 2 reactors, 3 wash vessels, and 1 centrifuge. After specifying which equipment is associated with each suite, it is necessary to revisit the product recipes in order to enforce suite allocation for relevant sections of the process. For instance, the reaction section in recipe AA must stay within a specific suite for all of its procedures. Note that if you do not see a recipe section node in the tree on the left-hand side, go to the Edit menu and select Preferences. Then click on the Show Recipe Sections in Tree option. To enforce the requirement that the procedures within a given section must stay within a particular suite, select the appropriate section in the tree and click the Properties button. Then select the Suite Allocation tab and click on the All Procedures Must Use Equipment from Same Suite option. Note that this process would need to be repeated for recipes BB and CC. Also note that the drying section of each recipe does not need to be updated, since the storage and drying equipment are not separated into specific suites in this example. Notice that once the suite allocation for a section is completed, a blue box surrounds the original icon for that section in the tree on the left-hand side. This blue box shows that the activities in that section take place within a specific suite. If you need to add additional sections to a particular recipe, you simply right-click on that recipe and choose Add Section. This will place a new section at the end of the recipe. Alternatively, you can right-click one of the current sections of the recipe and choose Insert New Section Before. After completing the suite definition and allocation, it is possible to generate a new Equipment Occupancy Chart, or EOC. Comparing this EOC to the one produced prior to suite allocation, it is apparent that some procedures have been automatically reassigned to different equipment. For instance, reactor R2 now processes the polymerization procedure for batches BB11, CC11, BB22, AA31, and BB33, whereas originally it processed batches AA12, BB14, BB21, BB24, BB31, and CC31. This reassignment was necessary to ensure that procedures within the reaction section of a given recipe stayed within the same suite. For instance, in the earlier file, batch BB14 starts in reactor R2, but then moves to wash vessel WV6. Once suites are specified, this material flow is not allowable. As a result, in this new EOC, batch BB14 correctly stays within Suite 2 for all operations in the reaction section of this recipe. In this particular example, enforcing suite allocation doesn't have a significant impact on the overall makespan of the production schedule. However, in other situations, the makespan may increase substantially. This next case explains how to track production activities and resolve conflicts on an ongoing basis. It expands upon the current file in order to incorporate production delays and required preventive maintenance activities. This case is useful for schedulers who will be working with SchedulePro on a daily basis to monitor and update plant schedules and to plan new campaigns. Tracking the status of production schedules in SchedulePro is facilitated by the concept of current time. Generally, the current timeline will be synchronized with the computer clock time. Alternatively, the current timeline could correspond to some other specific time that you want to use as a reference point to separate past and future activities. The current time feature can be activated by first clicking the Edit Schedule button on the EOC and then selecting the Current Time tab. The current time can either be specified by the user or set equal to the computer clock date and time. The red vertical line here represents the current time that was just specified. You can also adjust the current time by dragging the slider of the scroll bar at the top of the current timeline. Alternatively, double-clicking on the scroll bar moves the current timeline to that point. The current timeline results in the division of activities into three categories: completed, displayed by a crosshatch pattern, in progress, with diagonal hatch marks, and not started, with a filled pattern. The classification of activities is automatically updated when the current time is changed. The use of the current time facilitates the monitoring of the production progress. Note that the timeline at the bottom of this chart has been changed to absolute or calendar-based time rather than relative time, such as day 1, 2, 3, etc., in order to display specific dates and times. The switch to absolute time was executed by right-clicking an open area of the chart, choosing Edit Style, clicking the Timescale tab, and specifying the appropriate major and minor grid lines and format. As a schedule progresses, the completion of certain tasks may be delayed due to variability in raw materials, operator skills, performance of process controllers, equipment failures, etc. Such delays may lead to scheduling conflicts with future activities. SchedulePro enables users to follow the schedule in real time and modify activities to account for process delays and other deviations from the original production schedule. Scheduled activities can be modified through the Explorer tree and its views, as well as through the Gantt and equipment occupancy charts. In this example, the latter will be demonstrated. Let's assume that the polymerization reaction in batch BB13, the third batch of the first BB campaign, takes 2 hours longer than planned. Such a delay can be specified by right-clicking on the bar of the corresponding operation and selecting Operation Properties in order to bring up the dialog shown here. This delay can be specified by either increasing the duration of the operation from 14 to 16 hours or by adjusting its end date and time. Returning to the EOC, we can see the impact of the 2-hour delay in the reaction step of BB13. Its end time is now 2 hours later than before. This delay also propagates to the wash vessel, WV3, which leads to a conflict with the washing of batch BB22. Furthermore, the delayed drying of BB13 leads to a conflict with the drying of CC11. These conflicts are highlighted automatically in SchedulePro by the addition of extra equipment lines in the EOC, labeled with exclamation points, and by changing the outline of each conflicting activity from black to red. Note that when there is a conflict between two batches, it is the latter batch that the conflict is assigned to. At this point, the next logical step is to resolve the conflicts created by the initial delay. These conflicts can be resolved manually using the drag and drop capabilities of SchedulePro. In other words, the items that have scheduling conflicts can be shifted by clicking and dragging them to new locations on the EOC. The choice of which type of scheduled item to shift is made by clicking the Drag Mode menu here. Using this menu, you can specify that you wish to drag individual operations, or procedures, or batches, or even entire campaigns. Then you simply click on one of the scheduled items in the EOC and drag the cursor to the right or left in order to change the start time of that item. Notice that when I resolve the start time conflict for batch BB22, a new conflict is created with the start time of batch BB31 in WV3. This conflict will need to be resolved eventually as well. In addition to manually clicking and dragging bars on the EOC, conflicts can alternatively be resolved by using SchedulePro's conflict resolution algorithms. To do this, first right-click on the conflicting entity. Here you can see options to resolve conflicts for the corresponding operation, procedure, batch, or campaign. In this case, I will resolve the conflict for this procedure. As noted previously, resolving a certain conflict may generate new conflicts later in the schedule. It is generally a good idea to resolve conflicts in a stepwise fashion at a local level, such as a single batch or campaign, and proceed forward in the schedule until all conflicts are resolved. This allows you to see all the individual changes in the production schedule. Note that you can also resolve conflicts for campaigns and for the entire schedule by using the Conflict Resolution button on the Chart toolbar. I will use this button to resolve all remaining conflicts now. Note that in this example, resolution of the conflicts results in delays in the execution of many different batches. This is because the original schedule had very little idle time between batches. In general, adding a small amount of idle time to the schedule is desirable in manufacturing because the idle time provides flexibility for absorbing delays. Now that all conflicts have been resolved and the EOC has been updated, I will add a preventive maintenance activity to reactor R1. To do so, I simply right-click on a procedure in R1 and select Equipment, Add Outage. Here, I will create a one-time outage from 8 a.m. on May 1st, 2013 to 8 a.m. on May 2nd, 2013. Notice that the new maintenance activity has been added to the schedule, as shown by the gray bar here. I will now add a new cycle of campaigns, including a 2-batch campaign of recipe AA, a 4-batch campaign of recipe BB, and a 1-batch campaign of recipe CC. To schedule these campaigns through the EOC, I can click the Campaigns menu button and select Add New Campaign. On the ID Amount tab, I will choose recipe AA, set the number of batches to 2, and click OK. I will follow a similar procedure to add a 4-batch campaign of BB and a 1-batch campaign of CC. After adding these new planned campaigns, I can click the Schedule button and choose Schedule All Campaigns in order to add them to the EOC. The resulting EOC shows that the next batch to use reactor R1, batch CC41, starts after the preventive maintenance activity that we added previously. This concludes this multi-product facility example. For additional details on how to create models in SchedulePro, and for information on additional capabilities of SchedulePro, please refer to the SchedulePro manual under the SchedulePro Overview page of our website. In particular, the Chapter 4 tutorial in this manual has detailed information on equipment pools, changeover times, schedule adjustments, and much more. You may also refer to the online training videos under the training page of our website. Furthermore, note that the example files discussed during this video are part of the polymer resin manufacturing example that is shipped with SchedulePro. There is also a README file in PDF format associated with this example, which explains the example in greater detail. This can be downloaded from the link shown here. There is also a batch process simulation book chapter based on these files, which may be downloaded from the link shown here. This book chapter describes how to model, analyze, and schedule batch processes, and provides specific examples of batch process modeling in SuperPro Designer and SchedulePro. Please note that if you do not currently own a license to SchedulePro, you may download a free demo version of the software from the Downloads page of our website. This free demo version allows you to open all of the example files. This concludes this training session. Thank you for your attention.